as a result of this, I end up in this big rabbit hole of internet surfing and book reading. But either way, I'm going to tell you about it because the world is nutsos, and why not? I'm going to start off with one of the best presumed villain origin stories, because likewise, it is my villain origin story, and that is the story of Rosalind Franklin. So not only did Rosalind play a huge role in the discovery of the DNA double helix, but she also contributed to so much in science even after her death.
I am here for the drama.
But just really quickly, so we know what we're talking about, DNA is basically everything in your body that makes you the person who you are. Like, not even in a poetic way, it literally holds your genetic information, which is also something called your genetic code. So it's like a pretty big doo-doo for people who like to study things about organisms or human beings, and it pretty much meant you were the shit if you were trying to find out the DNA structure back in the day. So here we go. Rosalind Elsie Franklin was born on July 25th, 1920 in Notting Hill, England. She was second out of 5 siblings, and apparently she always excelled at school, and from a young age of like 12, she literally knew she wanted to be a scientist. So after Rosalind graduated high school, she started at Newnham College in Cambridge studying physical chemistry. And as crazy as it seems, there were not many options for women to attend post-secondary school at the time. But like most schools didn't even allow for women to study at the school. And even if they did, like in Rosalind's case, they had a quota at Newnham, and I quote, that women should not exceed 10% of the male undergraduate body. But I guess at the time was like so progressive. But most of the accounts that I read up on Rosalind said that she was like the type of go-getter who took no crap from anyone, and yeah, basically that's how she ended up in college. She started her freshman year in 1939, which was also the beginning of World War II, but this did not stop Rosalind from going to school, because this is exactly where her interest peaked with X-ray diffraction and her interest in studying the formation of crystals. And do not fret, we will absolutely be getting more into X-ray diffraction in a little bit. Eventually, Rosalind graduated from Newnham in 1942, and afterwards she kind of like floated around unsure of what to do until she met Dr. D.H. Bangham of the British Coal Utilisation Research Association, or also known as the BCURA. So he had basically collected graduate students to do coal and charcoal research because, mind you, it was in the middle of World War II, and activated charcoal was being used in gas masks because apparently it's like an absorbent for other gases, so that would be useful for like poisonous gases.
I also love how I'm just like going off like I know exactly what I'm talking about.
And while she was doing research at the BCURA, she went ahead and tried for her PhD and started writing a thesis, which is called The Physical Chemistry of Solid Organic Colloids with Special Reference to Coal. And having success with that, she received her doctorate in physical chemistry at Cambridge in 1945.
I feel like I kind of just want a doctorate because I want to sign off my emails with like, PhD.
So she's literally a Dr. Franklin now. Thank you. And the rest of her time at BCURA was spent doing more hypotheses and writing more papers with colleagues until 1946 when she decided to step back and do some traveling. And during her time off, she got to see like a lot of her old school friends who were probably doing like similar research things as her. But this is how she got acquainted with a guy named Jacques Mering. So Jacques Mering and his colleague Marcel Mathieu were said to be crystallographers, which meant they kind of just studied crystals. Anyways, this was great for Rosalind because that meant she was able to do lab work at the State Chemical Laboratory in Paris with Jacques. And even better because he specialized in X-ray diffraction. Okay, so I'm gonna like try my best to explain X-ray diffraction because this is pretty important. So basically, X-ray diffraction means using an X-ray on a specifically crystallized material to find out the structure of said material. And by doing that, you could like take pictures of what something might look like. Obviously, that was like the tiniest sliver of what X-ray diffraction really is, but I hope you kind of understand the gist. So for the next 3 years, Rosalind got to study and learn all about how to apply X-ray diffraction on different substances. For example, the ones she studied at the BCURA, which was coal. Apparently, she got really good at using X-ray to take super cool images, might I add, that no one has seen before of crystallized solids. And this genius of a method was exactly what she used when she got the also famous photograph 51, but I'm getting too ahead of myself, so I'm gonna stop and go back. So in June of 1950, Rosalind got a 3-year Biophysics Lab Internship at King's College. This was directed by a physics and biophysics professor, J.T. Randall. She finally got to start her work in January of 1951, where she used the same methods of diffraction, but instead of looking into the structure of coal, she started research on biological molecules, which is so cool. This is also when she got introduced to a guy named Ryan. Oh. So his name is Raymond Gosling, and I said Ryan Gosling. Wow. So his name is Raymond Gosling. Anyways, now I introduce a man named Maurice Wilkins. So Maurice was J.T. Randall's assistant director at King's and was also studying X-ray diffraction to get a better understanding of the DNA structure. But at the time, he was not very successful. And this is literally like the most awkward part. J.T. got Rosalind to take over Maurice's X-ray diffraction work because she had more experience. I'd also like to assume that Maurice was kind of blindsided by this whole situation because he was real pissed. Like, even other colleagues were mad. I don't know, I feel like Maurice was more upset that he and Rosalind were doing the same type of diffraction work, even if he knew she had a lot of previous experience with Jacques in Paris. And I guess at that point too, it was still kind of rare to see a woman in a lab setting, but in Rosalind's biography, which I will link in the description, it said that 8 out of 31 researchers were women, and that was actually like J.T. Randall being woke. King's was really onto something. They had figured out by manipulating living matter and making it into crystal form and looked at closely that they could actually see the arrangement of the molecule and therefore get a better look at to what genes might actually look like, which is so cool. And this is now something called crystalline DNA. Now come in James Watson. He saw Maurice speak about the progress of King's Biophysics Lab in 1951 at Naples. Maurice mentioned that this crystalline DNA possibly had the chance to be captured in 3D through, and you guessed it, X-ray diffraction. James Watson was also doing studies about DNA, and he was hoping to explain how genes replicated. And if anyone has taken a high school science class, you probably have heard of the term DNA replication. Anyways, this was when James got acquainted with Maurice. And again, now entree Francis Crick. Francis Crick was also in the field of X-ray diffraction, but instead he was studying protein at a research unit in Cavendish. And because a lot of DNA is similar and related with protein, this is how Francis Crick and Maurice Wilkins were acquainted. And you might be wondering why I keep bringing up Maurice's name related to the X-ray diffraction, and it's because he continued doing his research after he kind of got booted by Rosalind. But in the meantime of everything, Rosalind was still doing work with Raymond. They were using something called a microcamera, which would basically capture the image of any diffracted particles. And Rosalind, being a smart girl, used a little bit of chemistry to actually adjust the humidity in the camera to get really cool, clear pictures, which apparently were better pictures than anyone had seen before at the time. Their work stemmed from realizing that there was 2 forms of DNA. One was when it was hydrated, it would get really long and thin, and the other, when it was dried, would just go back to its normal shape.
I also totally forgot to mention this, that Raymond and Rosalind both decided that an appropriate name for the hydrated form of DNA would be B form of the DNA, and the dry form would be the A form of DNA.
And at this point, people at King's were starting to suggest that the structure of DNA was a helix, but just like anything else, they needed more proof to support their claim. Knowing more about the A and B form of DNA, Rosalind went full speed ahead with her X-ray diffracting. It was a glorious day in 1952 with an apparent 100 hours of X-ray exposure on this DNA that was shifting from A form to B form, like wet to dry. A photograph was taken, and that turned out to be the first very clear picture of vDNA. It was the first proof that DNA actually had a helical structure, and Rosalind named this photo Photograph 51. Like, now it's the most important picture in biology, like, whatever. By early 1953, Rosalind took her time to analyze all of her data and concluded that both forms of DNA had a double helical structure, and then started to write a manuscript about it. Remember James Watson and Francis Crick? They were also doing the exact same studies on vDNA at Cambridge. They had come up with a bunch of different models with calculations to try and understand and explain its true structure. But Watson and Crick were the first to publish their manuscript in April of 1953, and this is where they state that DNA has a helical structure with spiraled strands wrapping around each other. And you ask, how did they confirm this? Without Rosalind's knowledge, Raymond showed photograph 51 along with a lot of other data to Maurice. And what did Maurice do? Maurice literally showed Watson and Crick the image they were hoping to get to confirm their answer, which was evidence of a double helix. Like, I understand that Watson and Crick had an accurate answer, but I have a real personal vendetta against Maurice Wilkins because, like, did you take the photo 51? Did you get Rosalind's permission to show them photo 51? I don't think so. And just like that, it was over. At the end of the day, Rosalind did publish her 3-part manuscript, which included all of her information about the X-ray diffraction and the B and A structure of DNA. Later on, Rosalind had plans to do work at Birkbeck College in the crystallography lab. She did so many studies and research about other subjects like RNA, bacterial viruses, and even other cellular organisms. Now, this part is a little bit sucky. In the year of 1956, Rosalind was diagnosed with ovarian cancer due to her crazy exposure to X-rays. She underwent crazy surgeries and therapies for the next couple years, and get this, she literally still went into the lab and did her work and research. Like, nothing stopped her. And sadly, on April 16, 1958, Rosalind Franklin passed away of ovarian cancer at the humble age of 37. Unfortunately, being the time that it was, there wasn't really a lot of protective measures surrounding work with X-rays. Ionized radiation, which is the type of radiation used in the context of X-rays, is at like a crazy high energy. And there's a lot of things going on with that type of radiation, which causes a lot of damage to your health. And I think it's really easy to forget that during these times, they did not have the same type of safety precautions that we do now. And it just sucks because Rosalind's life was cut way too short. She was an amazing woman who had so much potential to like discover so much about this crazy, crazy world. James Watson, Francis Crick, and Maurice Wilkins were awarded a Nobel Prize in 1962 for their discovery of the molecular structure of DNA. They didn't even mention Rosalind's help in their research. But the more her story was shared along with photograph 51, the more people started recognizing her great work and true dedication to science. Rosalind represents so many women in science who are cut short of opportunities, and I heavily encourage you to go read more about it if you found it interesting. And with that, I literally think the sun is rising. Oh my gosh. That is not okay. So my description will have my Goodreads and every other resource that I use to make this video, as well as my socials. So thank you.